Hey guys, hope you're well. So in this lesson, we are going to talk about a pulse. So I first just want to play this animation for you, which is from a website called PHET, and they make all of these simulations. So let's have a look. Okay, so what we can see here is this thing that you can see moving on the screen right now. That is called a wave. Okay, so let's just make some notes here. This, what we can see moving, is a wave. Just like you see a wave at the ocean, let's actually slow it down a little bit, okay? And so that is called a wave. Now, we will be looking at waves in future lessons, but the reason I wanted to show you that is by looking at a wave, we can understand what a pulse is. So let's quickly pause over here. So we've already said that the entire structure is called a wave. But if you had to go and look at each little part, so for example, that part over there, or maybe that part over there, or for example, that part over there. Now those individual parts are, you can think of them as pulses. So what pretty much happens, and this is going to make more sense in a few moments, but if you take a whole bunch of pulses, which is like a single disturbance like that, and you put a whole bunch of them together, then you get a wave. So let's just say here that many pulses make a wave. Okay, so let's quickly go and make a single little pulse now. So if I had to just press this little button here, well, let's put it in normal. If I just click it once, that is a pulse. Can you see a pulse is a single one? Okay, let me show you again. And now let me just change a few settings here so we can make it a little bit bigger. So there, that is a pulse. A pulse is a single disturbance in a medium. A medium is like another word for material. Okay? And then I showed you that if you have many pulses, then it creates a wave. We said that if you have many pulses, then that'll create a wave. Okay, now we're going to talk about a lot of the properties of a pulse. The first property I want to talk about is this distance over here. So from here up to here. Okay, that distance is going to be called the pulse length. That is your pulse length. And then this distance from the bottom, like this part over here, up to the top, that distance is called the amplitude. Amplitude. Okay? So that distance that I've showed there, that is called your amplitude. Now, in class, have you ever heard your teacher mention the word transverse? Well, what we're going to look at that now. What does transverse mean? So to be able to look at that, I need you to do something for me. When I begin this next pulse, I want you to keep your attention on this particle over here. I want you to see what is going to happen to that particle. Is it going to go, either it's going to go left and right, so like one of those two, or it's going to go up and down. Now, I want you to try to think about that. I want you to look at that green particle and see what it's going to do. Okay, you ready? Let's do it. Okay, so here we go. Now, I'm going to go little bits at a time, okay? So I'm just going to fast forward little bits at a time. Look at that green molecule that I told you to look at. Okay, here we go. Are you ready? Okay, have a look at this green molecule. Okay, watch. Look at that. Did it go up? Look at that. It's going up. And now look what it does. It goes down. How amazing is that? I find this amazing because if you look at a pulse, it's moving from left to right on your screen. But how can that happen if the particles, if you think about the particles, what are they doing? They're just going up and down. That is incredible. Now, it actually makes sense if you think about, have you ever been to a sporting event, like at a big stadium, and they do something called the Mexican wave? Maybe you've seen it before, and maybe you've been a part of it. It's where you are sitting in a big crowd watching a sporting event, and then people start standing up next to each other. And if they do it in the proper way, it almost looks like, and then you know when they stand up and then they put their hands up. I'll try to find a little picture now or video now shortly, where everyone stands up and puts their hands up in the air, and then you see the wave going around the stadium. So the wave is going around the stadium, but what is every person doing? Are they standing up and down? Yes, they are. They're not moving left and right. They're only going up and down. But it makes this effect that the wave is going from left to right, or it's going around the stadium. And that is exactly what is happening over here. So here we have a Mexican wave. Can you see the people who are standing up and then they sit down, and look what happens. It feels like there's a wave coming towards us. Here it comes, here it comes, here it comes. Look at that. I wonder if you've ever been part of one of those, and then watch as the wave moves on. Look at that. You can see how the wave goes all around the stadium. Now remember that every single person sitting in that stadium, they did not move left and right. They only went up and down, but the wave went left and right, or just to the one side. So how cool is that? That is what transverse means. Transverse is when the particles, okay, now remember the particles are these individual little things. It's when they move at 90 degrees, or let's just say, 90, that is degrees over there, hold on, to the direction. I should have actually said, transverse pulse, to the direction of the pulse. Your teacher might not say 90 degrees, your teacher might say they might move perpendicularly, so perpendicular, like that. So perpendicular means that if the wave is going in this direction, so the wave was going from left to right, but what are the people doing? They are going in this direction. They're moving upwards and downwards. So that makes a 90-degree angle over there. And so that is what transverse means. Transverse is when you have 90 degrees. What we're going to look at now is something called the superposition principle. And we're going to look at constructive and destructive interference. So here I'm going to start one pulse. Okay, so there we've got one. Then I'm going to make another one. Now, so what we're going to do now is I'm going to create one pulse, okay? So there goes one pulse. I'm going to press pause. I'm going to change the size of the amplitude because I want to make another one now. Let's make the next one 0.3. Okay, let's just let this run a little bit longer. And now we're going to start another one. We're going to now have a look and see what happens when these two pulses go into each other. Okay, so I'm going to put a little reference line over here, and we can see the height of that one is currently over there. Now look at this carefully, and I also want you to think about what happens after they go into each other. So look at the small one and look at the big one. Now let's see what happens when they go into each other. So I'm going to do it in slow motion. Have a look here. Look at the height. Look at the height. So what we can see was that we originally had a small one, and then we had a larger one. Okay, and when they go into each other, the two heights, they simply added together. Okay, and that's why we can see that we are now higher up than what this original reference line was at. Another thing I want you to remember now when I press play is that we had the smaller one on the left hand side and then we had the larger one on the right hand side. Now all that's going to happen once they've gone past each other is that the smaller one is just going to end up being on the right hand side and the bigger one is going to end up on the left hand side, and then they're just going to carry on as if they never even saw each other. And then I'll play this again for you so you can just see everything. Okay, so have a look. Okay, so I'm going to fast forward. Now look, the big one's going to carry on going to the left. Look at that. And the smaller one carries on going to the right. How cool is that? And there we go. Let me show you that all again. So we start off with a single pulse. Okay, so let's do a single pulse. Then I'm going to create another one, which is going to be a little bit smaller. And then have a look at this reference line. Okay, that's the height of it. So now I'm going to create another one. So let's create another one. And now they're going to go towards each other. Okay, now have a look carefully what's going to happen. I'm going to play it a little bit faster this time. So see, you have the smaller one on the left, and then you have the bigger one on the right, and look what happens. When they combine, they become larger, and then once they move past each other, they just carry on as if they didn't even see each other. You see that? Let's see if we can... Oh no, now they're going down. Never mind, we'll talk about that at a later stage. Okay, so let's try to summarize a little bit of what we just saw. So we can say that when two pulses meet each other, we can use the superposition principle, which states that, oops, let's get rid of that little line, we can add the amplitudes together. Okay, now we're going to talk about constructive and destructive. So when the two pulses are on the same side of the equilibrium, I'll talk about that now. Equilibrium is just this line that goes through the middle. Okay, so when I say that two pulses are on the same side, then they're both maybe above, like that, or maybe they're both below, for example. Okay, so when the two pulses are on the same side of the equilibrium line, then we call it constructive. Let's write that better. Interference. Okay, now the next part I'm going to show you what destructive interference is. Now I'm going to try to show you destructive interference. Okay, so what we have happening now, what we see happening, is we are going to have this pulse over here, which is above the equilibrium line, and then we have this pulse over here, which is below the equilibrium line. And so if, for example, you had to look at the reference line, which we can see over there, then have a look what happens when these two meet each other. Okay, so I'm going to do it slowly at first. So you see what happens, look what happens. There's what happens when they meet each other. And then they carry on. As if they didn't even see each other. They just carry on normally again. Okay, now I'm going to show you going a little bit faster. So have a look. And there we go. Okay, have a look if they meet. So here it is once again. I'm going to go slow again. There we go. They've met each other. And then they move apart. As if nothing, as if they had never bumped into each other at all. Okay, so when two pulses which are on opposite sides of the equilibrium line meet each other, then we call it destructive. Destructive interference takes place. So what we're going to have a look at now is we're going to go do calculations with constructive and destructive pulses meeting each other.